Hi, this is a quick tutorial on energy bar charts. Each bar chart represents a system represented by this circle right here. So what you would do for this first example is water. So we would write water right here in this circle. Different bars in the diagrams represent kinetic energy bars or potential energy bars. So we're trying to show that these are energies that are either moving into the system or coming out of the system. Also, if we're looking at kinetic energy, then if you have something that's at room temperature, you're going to show 2 blocks for liquids. For potential energy, solids is 1 block. If something is a liquid, it's got 2 blocks of potential energy, and for gases, it's 4 blocks. So let's try this first example. So for this first example, we have energy, or let's look at it. Water is heated from 20 degrees Celsius to 80 degrees Celsius. So that's like from room temperature to pretty warm. All right. So we have 2 bars for kinetic at room temperature, and then 2 bars for potential energy because it's liquid water. So now when you heat water up to 80 degrees, it is going to have a higher temperature, meaning the particles have a higher kinetic energy. So we can put, instead of 2 blocks, we could make 3 blocks, like so. For potential energy, since water's potential energy at the liquid state is 2, and when you heat water to 80, it's still a liquid, then we would keep the potential energy to 2 blocks. So now, what has happened? Well, clearly, the system, that is the room temperature water, has gained a block of energy, right? It's gone from 4, it's gained 1, and it's gone to 5. So therefore, this, being the water, has actually gained a block of energy. So we can draw a block with the arrow pointing into the system. All right, so that's that one. Now we're going to go ahead on to the next slide. So we're going to move over to example 2. Example 2, liquid at 0, so that's frozen. No, sorry. So that's liquid at 0 is turning to ice at 0, right? So initially 0, so we're going to put the lowest amount of kinetic energy. So since the temperature has not changed, temperature and kinetic energy are related, so we still have that much kinetic energy. So I'm going to go ahead and put the block of kinetic energy, same temperature, so same amount of kinetic energy. Now this liquid, though, is going to turn into ice. So now, potential energy-wise, you've gone from the water particles being further apart from one another to being more ordered. Not necessarily, well, we're just going to say it's more ordered. So we go down to 1 potential energy block, right? So then we go from 3 to 2 energies. So 3 minus 1, this is high math here, equals 2. Okay, so energy is conserved. And so to show that the system, the liquid at 0, has lost energy by the time it's turned into ice, we have the energy flowing out of the system. So we draw the arrow pointing out of the system. We can draw 1 block to show that 1 block of energy. Doesn't matter if it's potential or kinetic, even though here we know that it's the potential that contributes to this loss of 1 bar. So yeah, that's a bar. Okay. And that's it. And I am done. Hope that helps. You can now go back and do the rest of the worksheet.